We're continuing with the back page of the AP Exam Review Worksheet 2, number 5. Which of the following is a solution to the differential equation dy over dx is equal to 1/3 y to negative 2 with initial condition of negative 1, y of negative 1 equals negative 1. So we can go through our steps to solving differential equations. So separate the variables. We want the y's on the left, our x's on the right. We can write this as dy over dx is equal to 1 over 3y squared. And if I do cross product, I get 3y squared dy is equal to dx. Okay, and if I have that, then I'm going to go ahead and move the 3 over to the other side, and I'm going to make it integral of y squared dy is equal to 1/3 dx. Okay, so now let's go through our integral steps, the appropriate integral steps for each side. So on the left side, go through power rule. Integral of y squared is y cubed over 3. Integral of a constant, 1/3 will be 1/3 x plus c. And once we have our indefinite integral, now we can use this order pair to help us solve for c. So we can take negative 1, plug in for x, take this negative 1, plug in for y, and then solve for c. So we get negative 1/3 is equal to negative 1/3 plus c. Add 1/3 to both sides, we get y equals 0. So y cubed over 3 is equal to 1/3 x plus 0. Therefore, y cubed is equal to x. To solve for y, we take the cube root of both sides. So y is equal to cube root of x. And we know x cannot be equal to 0. Okay. Let's look at number 6. Okay. Because if x is equal to 0, then that will cause y to be equal to 0, and we can't have y be equal to 0. That will cause this derivative to be undefined. Okay, number 6, equation of the line tangent to the graph y equals x cubed plus 3x squared plus 2 is at its point of inflection. So let's think about where point of inflection is. Point of inflection is going to occur where f double prime is equal to 0. Okay, doesn't mean that just because f double prime is equal to 0 means that there is a POI, but this is going to be a potential. This is where POIs are found. Okay, by setting the second derivative equal to 0. Also, we have to confirm that there's a change in signs on either side of that critical point in order for us to fully confirm that that critical point is a point of inflection. All right, so if we want to get to f double prime, we have to work our way down to that derivative. So here's y. So y prime, or f prime, will be 3x squared plus 6x plus 0. Find the derivative once again. 3x squared becomes 6x, 6x becomes 6. We set the second derivative equal to 0. Factor out the 6, and we solve for x, and we get x equals negative 1. Okay, and then on either side of negative 1, if I plug negative 2 into the second derivative, I'll get a negative value. If I plug 0 into the second derivative, I'll get a positive value. So we see that this is going to be a point of inflection at x equals negative 1. So this is the order pair that we're talking about. We're talking about the order pair at negative 1, and if I plug negative 1 into the original function, I get negative 1/4. We're trying to find the equation of the tangent line at this point. So here's my order pair. If I want to find tangent line equation, I also need to find the slope. So to find the slope, I'm going to have to plug negative 1 into the first derivative. So negative 1 gets plugged in for x. We get 3 times negative 1 squared minus 6, or 3 minus 6 is negative 3. Here's our slope. Here's our order pair. So negative 1/4 and negative 3. Our tangent line equation is y minus 4 is equal to slope negative 3 times x plus 1. And if we solve for y, we get y is equal to negative 3x plus 1, answer choice A. Okay, number 7. Rectangle with one side on the x-axis has its upper vertices on the graph of y equals cosine of x. So here's y equals cosine of x. This is the curve here, parabola-shaped graph. What is the minimum area of the shaded region? So we're dealing with area and we're dealing with area here. So we're trying to optimize area. So we want to find the area of the shaded region. Okay. Okay, so the area of the shaded region, we're talking about dealing with a prime of x. So we know that our area of this region is going to be 2x times y. So I think it's a shaded region, but we're dealing with this rectangle here. Okay. And in other words, to get this in terms of x, we know that this point on the graph will be touching the cosine of x. We know y is equal to cosine of x given here, so I can replace cosine of x with cosine of x with y. Replace y with cosine of x. So here's our function. To find the derivative, it'll be f prime g plus fg prime. And then we can set our derivative equal to 0. So to solve for x here, we can bring sine over to one side, divide the cosine, and then we get tangent of x equals 1, because that's what sine over cosine is equal to. And then using our calculator, we get x is equal to 0.7853. Okay. So 0.7853 is going to be the maximum that this rectangle is going to be. Okay. So if we plug 0.7853, we plug this into the function, we get 1.1107, and 1.1107 is actually the area of this rectangle, but we want to find the area of the shaded region. Sorry to backtrack on that. It is asking about the shaded region under here, but we're going to use this to help us. So we found the maximum area for this rectangle, which will then produce the minimum area for the shaded region. So the shaded region is the integral from negative pi over 2 to pi over 2 of cosine of x dx. So that will give us the area of the entire region, including everything inside. And then if we subtract out the rectangle, then we're left with 0.889, and that will match with answer choice B. Number 8, a rectangular area is enclosed by a wall on one side and fencing on the other 3 sides. If 18 meters of fencing are used, what's the maximum area that can be enclosed? So here's the wall, and the fencing is only on 3 sides. We know the opposite sides have the same value, so I'll call these x's, and I'll call the vertical y. Okay, we're told what the perimeter is. We know that if we add the lengths of these fencing, it'll total to be 18 meters. So we can say perimeter is 2x plus y is equal to 18. We know the area of the region is x times y. So we're trying to maximize area. So we're trying to get our area equation down to one variable. So we can use the perimeter equation to help us get there. So I'm going to solve for y for perimeter. So y is equal to 18 minus 2x. Plug 18 minus 2x in for the y of the area. Now we can work towards finding the derivative. I'm going to distribute first, make it 18x minus 2x squared. Now it looks like everything is ready for us to just easily apply power rule. So 18x becomes 18, 2x squared becomes negative 4x. We set our derivative equal to 0, and then we solve for x equals 9/2. So we know that maximum area will be achieved when x is 9/2. So if we want to find the area at 9/2, we can plug 9/2 into one of the area equations. So 18 times 9/2 minus 2 times 9/2 quantity squared will give us 81/2 square meters.